Right, so good morning, everyone. Welcome to Thursday morning session. The few that are here, I'm assuming most of you are still in bed or are trying to stay awake, or probably just opened the stream and went back to bed in any case. So, what we're going to do this morning is we're going to look at random access files. Now, you'll see that random access files, the slide sets are not too long. It's very short. The concept itself is very easy, and to be quite frank with you, it's generally when you do random access files, there's other technologies that are more suitable to or more suitable for its purpose than using it directly with VB. So we're not going to explore it too much. We're going to cover the concept entirely, but the use of it is going to be limited. So there is no practical random access file. But you'll see from the actual implementation or the example code that's provided, it's not really that difficult. It's just a different way of considering concepts. So before we get started, let's see who is awake and who is still asleep. So what's the difference between a sequential no, my own brain is sleeping. What's the difference between sequential files and random access files? You can tell me.
So
Yes.
I think sequential is when they go from ascending to descending or descending to ascending. Then random is just picking up any one of them.
Okay, you're kind of there, but not 100%. Oliver?
I think that sequential is when you go line by line in a file, whereas random is when you want to a specific spot in the file.
All right, that is a lot closer. Random, yes. Sequential, it's not necessarily line by line. So your code runs sequentially, that is line by line, yes. But as I showed you guys on Tuesday, I think on Tuesday, if you put things sequentially in a file, it actually puts it in one line. It doesn't actually go one line after the other, but it divides them, so it's one after the other. Um, but yeah, that the answer like that would be accepted as well. So when we look at things sequentially, it's one after the other, not necessarily one by one, not necessarily in one line though, but it's one after the other. And when we look at random access file, they are at or they're located in specific locations. It's not defined as one or one after the other. And it's not just as simple as opening up the file and start reading it. It takes a bit more to read random access files as well. So first things first, let's look at what we're going to do. So the first thing we're going to do is we're going to look at how to write to a random access file and how to read from a random access file. Now, when we talk about random access files, remember, things are stored in random locations, or we say random locations, but they're stored in specific locations, and a part of the data set is used to determine where they're going to be stored. So when you look at random files, you'll generally get this notion of a key being used. I'm saying a key because it's a phrase you'll be using in your second year, but basically it's a piece of information you are going to use to identify the information or to locate the information. All right, so random access files. A token, not. I don't want to use the term token. So in 2A, you'll learn of keys. Keys are used to identify information. Now there are various different forms of keys. You've got a primary key, a secondary key, a candidate key, a you've got surrogate keys. There's a whole bunch of keys, but the purpose of a key is to identify information specifically or uniquely. Now, in random access files, that key is going to help you a lot. Now, a token, that's more of a security term. It's not specifically used for unique identification. Um, but it kind of serves a similar purpose. But I'm not going to go too much into that. All right. So when we look at the structure, what's the one thing we know about our sequential files in VB of how it's being stored, except for that it's one after the other? Is there any other order to it? Or is it just simply stored as we read it? And there, half of the class fell asleep. All right. So when we work with sequential files and files in general, Visual Studios doesn't handle any type of file structure. It's stored as a DRED, yes. Uses a delimiter, going into different concepts there now, but there is no specific structure in which it's being stored. There's nothing that dictates it needs to be in this format, it needs to be of this size. Everything is handled by the user, not by Visual Studios. So we have to create the structure ourselves in order for these files to work correctly. So in Visual Basics, we do this by writing X blank record. So a blank record refers to the fact that you've got that empty space, and then whatever is not filled by the user is reserved with an empty space. Now the empty space generally is just it's nothing. It's just null, but it comes down to the fact that those empty spaces reserve that allocation for the maximum usage of that data type specifically. And I'll get more to that I'll discuss that a bit more when we start actually putting data into the blocks. So when we look at our information, we're going to consume a certain amount of data out of this blank record. And the rest of the information itself is either going to be empty or filled with something else, depending on how much information we'll be using. So one thing you need to keep in mind is you need to now know what you're storing and how many bytes it consumes, because it's one thing you'll have to track when using random access files. All right, so let's get into the actual example. So over here we've got a record structure of a student, fairly basic one. We've got an ID, which is of type integer. We've got a VB fixed string, public surname as string. Now, this will be something new for you. This VB fixed string, you see a blank.
This is blank.
Is anyone else's screen blank? So on my side it's displaying. All right, you can see it. It's fine. Okay. It probably just blanked out for a moment. It sometimes happens to me as well. I just assume you guys can see it if my screen blanks out. All right. Where was I? VB fixed string. So this VB fixed string it's basically saying that you have a string of 15 characters and a maximum possibility of 15 characters, essentially. But what it is also telling you is that there's going to be a maximum and a minimum of 15 characters that are being stored. Whatever is not filled will be filled with empty character spaces, basically. So the size being stored will always be of 15 characters. And it's very important that you understand the fact that it's always going to be storing 15 characters, regardless of the empty spaces. Then you've got a average as a double. And these data types are now important. So in the first semester, you would have learned how much space they consume. And now, sorry, and now you'll have to know the amount of bytes they're going to be using. No, it's not always 15. So in this case, we're just using 15 as an example. So this example uses a fixed character size of 15. Generally, when you get to databases, this allocation is a bit larger, but it's normally based on what you expect, the maximum expected value. So if you look at a surname, if you can think of the longest surname you can think of, that's the size of the data type you want to make it. In general terms, I normally say that you can make it of the maximum size because of the data type you use. It's not really going to waste that much space for databases. But in this case, try and not make it too big because your file size will grow quite quickly if this increases. Specifically with strings, because a string can consume a file size very, very quickly. All right. So in this case, we're looking at the integer that consumes 4 bytes. We've got the You've got the surname that consumes 30 bytes, and you've got the average that consumes 8 bytes. All right. Now, if you look at the actual storage or the actual usage being used, why are they all public? Well, it's in this is assumed to be, it's a record structure. So the record structure itself is private, but the values inside will be public, so that you can use them. So VB fixed string is a keyword. It identifies the fact that you have a fixed string length. The string will always be of length 15, regardless of how much information is being filled. So if you look at student 1, which is the example or the test data we are providing it, you'll see that the integer 5 consumes 4 bytes. So most integers of it, or all integers will consume the same amount of bytes because of the size limitation of int and how it's being represented. Baloy is 12 bytes essentially, because you've got 6 characters and each consumes 2 bytes, so that's going to consume 12 bytes. And then you've got your Boolean value, not your Boolean value, your double value, which will consume 8 bytes. So you've got your 4 bytes for your integer value, and you've got your 4 bytes for your decimal value. Now, in terms of information being stored, you can see that Baloy, the available space you have is the 4 bytes, the 30 bytes, and then the 8 bytes. And then the information being used is essentially the 4 bytes, the 12 bytes from the Baloy, and then the 8 bytes from the double, and then the rest is all empty. So what happens essentially to that empty space is if you represent it in terms of your file and you don't take that into consideration, you're going to lose the allocation of that specific location, or you're going to lose the position of that specific location if not considered. I know that sounds a bit weird, but you'll understand it in a second. So essentially what you have in terms of data actually being used is 4 bytes, 12 bytes, and then the 6 bytes for your average. And then the rest of that space is empty, unallocated. Now, if you're storing this, you don't actually need to consider the empty spaces. You just need to consider the total amount of space required for this record structure. One of the reasons why we're using a record structure here, so that we know exactly how much data is being used. So, quick math for you guys this morning. How much data will be used if we fill this to the maximum amount of information, or with the maximum amount of information? We'll discuss that a bit later. So we'll discuss whether this is going to be in the second semester test or not. Like you guys are saying 24 bytes, but keep in mind, we're looking at the maximum allowed data. So be very careful there. So you've got integer, which consumes 4 bytes. You've got a VB fixed string, which is of size 15, 2 bytes for each character, which means it will consume 30 bytes. And then you've got your double, which will consume 6 bytes. No. Remember, each character takes 2 bytes, Unicode. probably should have from the start. So it's going to be 30 plus 8 plus 4, which gives you the total of 42. And this is important to note. So our file stream and our binary writer. So now it's not the binary formatter anymore. It's the binary writer that we'll be using. So it serves the same purpose as the binary formatter. It also opens up a formatting based implementation, but you're essentially writing information to stream, but you're writing it as the given data type of each piece of that information. Now, that might sound a bit weird, and this concept is going to take you maybe a day or two to get used to. So, when we start writing this binary writer, the first thing you need to do is consider where is this information being stored. So one of these pieces of information you'll be using will be used as a key. So it's also one of the reasons why we're using a structure, a record structure. So the idea here is each record will have an identifier. There will be something that will identify the information. Now that information will be used to determine the location of the file or of the information. So if we get to, sorry, it's jumping a lot. So if we get to the actual writing, we use that information you're going to use to identify the student and multiply that by the number of bytes. So the reason we do that is the location you're looking for. So you're taking that identifier, which can be anything. It doesn't have to be the ID, but it's generally a unique attribute to that specific record. You multiply that by the maximum amount of data that's going to be consumed, because then you have your blocks. That's how many blocks it's going to be jumping. So whatever is being used to multiply with, it will always be of that fixed size, which means that it's always going to jump that allocation. So it doesn't fill up the information. Let's say the previous student, let's go 2000. 2000 only consumes half of the 42 bytes, and then the next student, 2001, consumes the full 42 bytes. But what will happen is in your actual file, it will store 42 bytes for the student 2000, so that the next student is allocated at the next bracket as well. Now, even if it's not using the maximum allowed allocation, it will make sure that the next student is stored at the start of the 43rd byte in any case. So you'll never have an overlap of information, and that is what the record structure is for, is the fact that you can store information and you can retrieve the information as well. And we're going to get to the benefits of that in a moment as well. So the next thing in this block is seek origin. Now, there are three different terms here. You've got seek origin.begin, which means you start searching from the beginning of the file. You've got seek origin.current, which looks at the current position in the file and searches from there. And then you've got seek origin.end, which starts at the very end of the file. Let's just get to that question. Does VB determine the maximum number of bytes for us, or do we need to calculate that? You need to calculate that for yourself. So if you're working with something like a string, you need to determine what size of the string you're going to be using, because you'll have to tell VB the maximum allocation of that string size. It's why we use that VB fixed string notation, so that we make sure that we're using a specific amount of information. Otherwise, if we exceed that, then we can't use a specific value in order to determine our blocks. So it's very important that you consider what the maximum allocation is going to be for data types. Integer Boolean and the averages are easy because the representation of those values are always in the same format. So whether it's 1 or 1000, the amount of space being used is the same. All right. Now, once you've determined the location of where you want to store information, the beginning part of that location, Then you can write the information. The information is still written one at a time. So you'll write your student ID, you'll write your student surname, and you'll write your student average. Or if you're using a different structure, you'll write each attribute of that structure inside that bracket or inside that allocation, and then close your file stream. So what if the number of bytes are wrong calculated? Well, if you calculated it incorrectly, then your sizes are going to be incorrect, and you're most likely not going to find the information you want. So what could happen is the fact that you'll have an overlap of information, and you'll probably override your information as well. Now, right now, we're just going to discuss it theoretically. Next week, Tuesday, we're going to show you what happens. We're going to show you what happens if you give the wrong size, if you give the wrong format. So we'll once again go through a practical, and then I will obviously intentionally break the code or break the implementation so that you can kind of see what happens if you break it or calculate it incorrectly or use it incorrectly, so that you can see what happens, so that you can identify it as well. But what will happen if you calculate the size incorrectly is, one, you'll have blocks that are too big, so you'll be wasting space, or two, you'll have blocks that are too small and you'll overlap information and start overriding information, which means the record itself is null and void, or the usefulness of the record will be diminished. You won't get the information you want anymore, which means it's not reliable, which means you can't really use it anymore. Can you track the number bytes as you store them in the different files? What are you referring to specifically now? So do you want dynamically allocated byte sizes? Well, each data type has a specific amount of bytes that it's using. So when you're storing strings, you're storing it as a Unicode implementation, which means you're using 2 bytes for every character. So you need to look at the maximum size allocation of that. Integers and doubles and booleans store a fixed number of bytes. So you just need to be aware of what that byte size is. And that is something that was taught to you in the first semester. I'll upload a reference document for you before the tutorials next week, just so you kind of have a reference of how much information is being consumed there. But these are things that you kind of need to be aware of when working with random access files. But look, it's not for you to be aware of it right now, but you're never gonna, or I'm not gonna say you're never gonna use it like this, but it's just the concept being taught to you, because like I said, there are far better ways of implementing something like this than using actual record structures. You'll use something like a database instead of using a record structure, because essentially this is the intro into a database. It's a very basic concept of how a database works. It uses a key to find that information, and then that key determines the block sizes as well. Or it doesn't determine the block sizes, but determines the starting point of each block. I don't want to say no, that you're not going to use records again. You are going to use records again in 2A, but not directly like this. But the thing is, it's a concept that you need to be aware of. You need to know how it works. You need to understand the concept so that you can better understand why databases are so useful. Right. So, looking at the information being stored once again, so what happens when you want to read this information? How would you retrieve it? How would you consider that? So, first of all, now that it's a record structure, it's not just a file that you'll randomly read and say, print out everything for me. You can do that. You'll probably just iterate through the blocks until you get to the end of the file itself, but it's not specifically the purpose of the application itself. So what you will do is, once again, you'll open up your file stream, you'll open up a binary reader this time. So for the record structures, you'll use a binary writer to write, you'll use a binary reader to read, and the first thing you want to know is, what information do you want to retrieve? So in this case, we're working with student. So what is the ID that you want? What information do you want? The user will provide you with the ID that is being sought. You will then take your file stream and seek. You'll search for that specific ID. So you'll take the ID, multiply that by the maximum data allocation of the record itself, and you'll start from the beginning of the file when searching. So the seek origin.begin. From that point on, you'll either find the student or you won't the student. If you find the student, you've got to establish a temporary variable for student 1 as student, and then you'll read. Now, this part is important. When you read the information, you don't convert it with the internal converters anymore. You now convert it with the binary readers converter. So you'll read the specific data types out with the reader itself. You'll have your binary reader dot read int32. Now, that already identifies your size there as well. So you've got the 32 or the 4 bytes that you'll be using. Hold on, I've got a reference here. Oh, yeah. Okay. So it refers to the fact that you're using the int32 format, which is your default integer. You'll then read your string and read your double. Now, one thing to keep in mind here, the format you use to store the information is the same format you have to use to read the information or the order. So if you store it in terms of ID, surname, and average, then you need to read it in terms of ID, surname, average. You can't change the order of that read and that write. Otherwise, you won't get the information and it will crash on that specific part you're trying to read, which is not in that specific order. Now, one thing to keep in mind here as well is if you seek this information and it doesn't find that spot, what will happen at that point? Now, this is something I'm going to leave up to you to try out. I know half of you are probably not going to try it out, and you're going to wait for us to show you on Tuesday what will happen. But I want you to think about it. If you're searching for information, that information does not exist in the file, what will happen, and what do you think should happen? So I'm not going to put it as a question that you can answer. You can answer it if you want to, but I'm not going to tell you the correct answer. So I want you to go and try it out. I want you to consider what is the scenarios there. What do you think is the scenario, and what is the actual scenario? And then once you've done reading that specific record that you were looking for, you close the file stream. Remember, the moment you open that file stream, you must close that file stream. So Mr. Control is a very good way of approaching this. The moment you write that line of creating a new file stream, you immediately below that add your close file stream, and then you code in between those lines to make sure that you always finish that close file. Because I can tell you now, and I've done it numerous times, once you start writing this file, you completely forget that you have to close the file. Especially when you work in your second year with databases. If you open up that connection, you most of the times forget to close that connection. The system crashes in the weirdest places. It doesn't crash there where it's not being closed. It crashes somewhere else in your program. So debugging becomes a bit more difficult because it doesn't actually tell you specifically where the issue is, because closing that file doesn't always, not closing that file doesn't always cause an error. It only causes an error some of the times if you're going to use that stream again. If you're not going to use that stream again, it won't actually cause an error. All right, so we have some guesses of what's going to happen. All right, so those are good cases, but like I said, I'm not going to tell you the answer here. We're going to show you what happens, but I want you to think about it. I want you to think about it logically. What do you think should happen, and what will happen? Now, there are different ways of approaching it. If you remember how we casted information itself, if nothing was found, there was a null reference, and if something was found, the information was filled. But now you're working with a file, and you're working with some kind of searching method. So this function itself what do you think this function is going to return if nothing is there? Because this function has a return type, so it has to return something. Otherwise, if it's not returning the correct value, not returning you an incorrect message statement or error, it's going to crash. So I want you to consider, is it something that we need to do a try catch on, or is it something that the system will handle it for me? And how would you do it if you had to code it out? All right. Now that is record structures. That is the intro to record structures. We spent more time on sequential because it's the first time you saw the concept, but now building on that concept because it's using the same format essentially. You still have your file stream, you still have some form of a binary format or binary writer, and you're still retrieving it like that as well. So you're writing itself and you're retrieving itself. Why does my keep on jumping to the wrong slide? So you've got the same thing. You're writing, you're reading, and you're writing and reading in the same order in which you provided it. But instead of writing the entire structure, you write the items one by one. So half of you are already probably thinking, okay, that sounds like an actual subroutine I'll be using to save information to this file. And if you're thinking that, good to you, because that is modular programming. You want to use things for specific purposes. All right, let's see the next question here. The system will handle it. You would get zeros. I see a double meaning there. If the system handles it, you get zeros for your mark, or the return is a zero, or zeros. The return. Well, once again, like I said, consider what the return type will be for that seek function. Is there a return type there? Because we're seeking file stream.seek, and down here we're using the binary writer. So just one thing to consider. All right. So are there any questions? I know it's just a that you're looking at right now, and you probably have a few questions of, okay, what happens if you're using different methods here, or if you use the current, if you use the end, what happens if you change the size, if you're using the incorrect size, what happens if you use a string here instead of an integer? Now, those are things we're going to show you. So if that is the type of question you have, then it's going to be answered on Tuesday, but we're going to show you that. But is there anyone that has an issue with the actual concept itself? Practically, we'll show you what's being done with the readers, the writers, and the data types, and the seek origin. But the concept itself, is there anyone that struggles with the idea of a random access file? All right. So where in the concept did I lose you? Because the idea of a random access file does get a while to get used to. Please explain the read string, the read int, and the read double part again. All right, so those are just the format methods. So you're reading an integer. So if you look at the data structure, data structure for our student is an integer, a string, and a double. Now, when we write the information, we just write it and it will write in those formats. So you'll have write ID, you'll have write surname and write average, and that will write it as an integer, that will write it as a string, and that will write it as an average. When we read it, we need to tell the reader what format it's reading so that it can convert it for. So it's not a fact that we have to go br.deserialize anymore. It's now br.readInt. The expected value you'll be retrieving is an integer. the expected value you will be retrieving is a string, and the expected value you will be retrieving is a double. So it's telling it specifically what information am I expecting. So instead of converting it, we're just retrieving it in the data type that it's being stored in and then placed directly into our temporary variables. It's a little bit of both. So int32 represents the amount of bits inside the format. So if you break that down, that is 4 bytes. So it's int32, so it's a 32-bit integer representation. Because remember, there's 8 bytes in a bit, and our integer is 4 bytes, which gives us 32 bits. So if you're using, if I'm not mistaken, Ms. Cottrell will correct me if I'm wrong here, I guess. Long int will be, I think, is 64-bit. If I'm not mistaken, I think I am mistaken actually. Let's just see. I think Ms. Cottrell linked the actual data sizes. So let's open up that document and quickly see. So long is 8 bytes. So you're looking at, yeah, you're looking at 64 bits. I was right. So you've got a byte. A char is 2 bytes. So one specific character has two bytes. This is now for Unicode. Your data format is 8 bytes, and it gives the normal format structure there as well. Decimals are 16 bytes. Doubles are 8 bytes, so it's the amount of information being stored in both. Please just keep that in mind. Integers are 4 bytes, long are 8 bytes. Object, that is slightly different though. So anytime can be stored in a variable of type object. Now type object is the default root object size inside inside Visual Studios or Visual Basics. So we're not really going to work with this, but you can store custom sizes or custom objects there as well. Then you've got your short byte, you've got your short itself, so that's a short integer. You've got a single, which gives you your representation. You've got your string, which depends on the platform itself. So if you're using Unicode, it's two bytes per character. And if you're using ASCII, it's 1 byte per character. You've got your U integer, U long, U short, and user defined. So those are things you'll generally, it's everything, it's you most likely never use those. I say most likely, but the chances are quite small that you'll use them. All right, but I'll put that into a slide for you so that you have that reference on hand. All right, I think I'm missing a question here. Yes, scroll down. Do we always have to specify that value? So you have to specify the maximum data allocation when you're using random access files. Because if you don't specify that size, it doesn't know to which position it's supposed to be jumping. So you need to be at all times at all times you need to be aware of the size you're being. At all times you need to be aware of the size of the blocks you'll be storing. I mean, for the read int. No, that is the, if you look into data, that's just the, that's how it's declared. That's the function name. It's int32. Because int has a short, a long, and then just your regular integer. So it doesn't say short int, long int. It says int16, int32, int64. And that represents your short int, your average integer, and your long integer. So it's just a reference to the specific integer format that you're using. Right. You'll most likely see that if you have an integer of a smaller size, so let's say you're using anything that fits into a small int, it will most likely not crash. I've never actually tried it like that, so we can test that out on Tuesday. But if it's something that fits into a 32-bit integer and will not fit into a 16-bit integer, and you use the 16-bit integer, it will most likely crash on you. So just have to have a look. I'm not actually sure if it will crash if you use a 16-bit or a 64-bit integer in a slot that's supposed to be 32-bit. Because keep in mind, when you say read 32, it reads that size. It looks at that size allocation inside your random access file, and that's how much information is being used. So if you're reading a 16-bit integer, it's only going to look at the first 16 bits of that specific information. So anything after 16 bits will be lost. That's why I think it will most likely work, but I've never actually used it like that, so I'm not sure. Yes. So if you have anything that exceeds a 16-bit integer, you'll lose that information. So you'll most likely see that the result you'll retrieve will be wrong as well, because it will cut off those bits, which means that the value you're retrieving is essentially the wrong value. Well, like I said, that's more something for next week, Tuesday, so we can look at it practically, because I've never actually broken it like that specifically. So I'm not too sure what the new Visual Studios will do with that. If I have to think in terms of programming concepts, if you're trying to retrieve a short bit and storing that into an integer, with a file reader specifically, I would make it crash, because it means you're reading the wrong information. If you're using it inside the program itself and you're trying to take the short int and put it into an integer, that I would not let it crash, because you're not really losing information there. You're just increasing the size of the actual memory usage. Is it fine if I update VB? We spoke about this yesterday. Yes, you can. At all times, you should try and keep up to date, unless you're working with something very important and you don't know what the update is going to change. But those are concepts we'll talk about when you're actually working on projects, because if you're updating something on your machine and you're working on a project, and something that you're using inside the project is being deprecated, removed, or updated or changed, you need to be aware of that, because one moment it will work and the next moment it won't work anymore. And you need to know why. You need to know what changed or what is going to change or how to fix it. I have an example for you, but I don't think you guys will understand that. It's a different language, which probably none of you will ever use. If you want to know, you can stick around after the recording and I'll explain it to you. All right. Are there any other questions? Interesting. I'll have to look up on that. Look, if you're not using option strict, then it will allow you to just convert, because VB will assume the data type and how it's going to convert it. Now, if you're using option strict, it's going to force you to convert it. You will still have to convert itself, but if you don't use option strict, you can essentially just pass the information and it will internally convert it to the data type you're using. But that is not good programming practice. You should always try and convert it, and that's something that you guys will probably enjoy about JavaScript, because JavaScript doesn't necessarily have a data type association with it. It just assumes the data type as it's being used, unless it's changed in the last 3 years. I'm confused on how enums work. All right. We'll be discussing enumerations again in this afternoon's lecture, and I'll also be releasing the enumeration slide probably either just before the TUT this afternoon or just after the TUT this afternoon, depending on how much information is going to be in the slides. I don't like releasing slides if it's just going to be one page, but generally I currently am sitting on about 4 or 5 pages. It just depends on the example we're going to use in the TUT this afternoon, but it's going to be more. So if you're confused about the enumerations, just pop into this afternoon's tutorial. I'll begin with enumeration so you can kind of see what's going on there. Okay, IDE related question. My VB highlights syntax in only 2 colors, blue and white, and it makes it difficult to track my code. How do I change it back to highlighting with a few different colors? Right, so that probably means that you changed that color option somewhere and you need to go and reset those color options. I'll just have to double check where to change the colors. It should be in your preferences under formatting. Or under error handling. I'll just have to double check on where specifically. Otherwise, you can just do a reset of your settings, and that will take everything back to basically factory resetting or factory defaults. But it just means you probably selected an option that only highlights those 2 specific codes or specific errors, or you change the color scheme in terms of what is being highlighted. It should be under, we'll have a look after the recording. I'll quickly have a look. Right, so I think if there's no more questions, I'm going to start the recording here. The questions that are being asked are not relevant towards the slide itself, so I don't want to waste the data of the people that are downloading the videos. Right, so for anyone watching the recordings, if you're confused about the record structure usage, please come to the tutorial next week. We will show you practically how it's being used. To be honest with you, I don't think we're going to test you on this. My personal feeling about this is the fact that sequential files are more relevant towards something that you would use inside Visual Studios. And if you're talking about random access files, I would rather use a database. You're basically talking about a database. I'd rather use a database. And with databases being so small these days, especially using SQLite, it's essentially just a file structure in any case. So I don't see the point in having to have you guys know how to code this from start to end specifically, but you need to understand the concept. That is one thing that will be tested. The concept itself will be tested. Practically not as much, most likely. But the concept itself will be tested. Please don't think it's not going to be tested. It is going to be tested either in your exam or your second semester test. But practically, I don't think we can ask you to do it practically. Depending. I personally think it's easier than sequential files in any case. But that's just my personal opinion about it. Right, so I'm going to stop the recording here. So for those, once again, those watching the recordings, please make sure that you understand the concept. And then if you're struggling to understand how it's going to be used, come to the Tuesday tutorial. We'll play around with it. Moscato generally does a practical, or one of the practicals on past papers with the implementation itself, whereas I will play around with the concept, intentionally breaking the things and showing you what happens if you use it incorrectly. All right. All right, guys, I'll see you this afternoon. And for those that are watching the recordings, I'll see you in a few moments. And once again,